Thank you very much, Stephen, for that kind introduction. So, as Stephen said, I'm the head of security research at BT. My job is to look 3, 5, 10 years ahead and protect, our own systems in BT, but also, come up with commercial opportunities for BT to actually protect the customers that we have. And I've been working with AI for almost 25 years. So what I want to do over the next 30 minutes is to share some of the lessons that I have learned, both good and bad, in terms of the use of AI in security, and hopefully with reference to what it means for IoT systems in the future. I'm not going to tell you where I'm a professor. You can Google that. I work in research and network strategy at the moment, and I'm going to talk about AI and cybersecurity in the future. So you all know that there was a Bletchley meeting around AI safety, and there was a declaration by AI superpowers that we really need to be thinking about AI safety and security. And I think that has very important implications in terms of the research that we're doing and the result of the research we're doing. Clearly, AI itself needs to be secure to be deployed. But I think when it comes to IoT, my view is that we need AI to actually make IoT secure because of the sheer volume of the devices that we have and the complexity of the capabilities that the devices have. You need that level of automation. You need that level of self-healing. You need that level of what I would call kind of immune system methodology, whereby your IoT systems don't necessarily need to be made secure by humans, but they actually have the ability to defend themselves a little bit, at least a little bit, before they get critically attacked or fail critically. So the number of attacks that we see, through the analysis of our network is increasing very rapidly. And the reason for these attacks is because some of the old threats are still around. Viruses are still around and worms and so on. And new ones are being invented all the time. We deal in BT with 6,500 potential cyber attacks a day. And that gives us a very, very rich pool of data to draw from and understand what is, what the future might look like. I think the future is this sort of question mark. That's what my team does. What are the tactics that are going to be used, and what are the new threats that are going to be developed? We already know, for example, that does the laser work? We know that autonomous malware is being built. AI is already being built into malware to avoid detection through standard techniques, and we're working very hard to develop new ways of behavioral-based malware detection. This is something that my team is working on. The most prominent malware used right now that companies are worried about is ransomware, clearly. And the tactic used to find vulnerabilities, supply chain attacks are on the rise. And I think this is very pertinent to this organization, right? I mean, there's a very complex supply chain in IoT, right? And people go on the internet and order a webcam that is cheaper than the rest of the webcams, and without really understanding where it comes from or who built it or what kind of security is in there. That's on the rise. But my team is looking at what are the new tactics and what are the new threats that are being developed. And when you look at AI and security, you really got to look at these 4 quadrants. A lot of companies are developing what I call cognitive cyber defense, which is how do you build AI into your systems, your products. And I'll talk a little bit about that in terms of what we're doing in that space, in research area, not necessarily, they're not products yet. But you've got to also understand that at the same speed that we're working to build security systems using AI, the bad guys are weaponizing AI. Okay? So, and I'll talk a little bit about this one. You also need to understand that when you put AI into your system, there are certain vulnerabilities that come with AI. And you need to be aware of them and work around them, essentially. And I'll talk about that. And of course, we need to make sure that the AI systems are secure, because if AI systems are compromised, people can reverse engineer those AI systems to actually try to get to your data. So the topic of homomorphic encryption, encrypted analytics, encryption in general is going to be very important when you use AI for securing IoT systems. And just before I go any further, my own view is that I don't subscribe to this view that AI systems are going to chase us down the street and kill all of us and take over the world yet. I don't think they are that clever yet, and they make very simple mistakes. And although they are growing in capability, they still don't have common sense. And we need to be aware of that when we use them in our security systems, because they do make very, very simple mistakes. Mistakes that they wouldn't make if you had the human in the loop. So a lot of our thinking in BT is about use AI where it makes sense, use automation where it makes sense, but don't let AI loose on your infrastructure to make automated decisions, because in our experience and in our research, that actually goes in the opposite direction of creating more work for our people and sometimes leading to catastrophic failures. So that said, let me talk about the weaponization of AI and what we see. Most IoT systems, and I'm generalizing here, most IoT systems have quite simple passwords, right? Now, AI systems have been developed that can break simple passwords within a minute. So you don't even have to be a hacker to guess the password for simple passwords. As the password gets longer and more complex, this system takes longer to actually crack it. But essentially, we have this hacking as a service now, whereby people are designing AI into programs to automate the process of hacking. You've all heard of systems like ChatGPT and so on, and they're great. And if you go into ChatGPT and say, write me a piece of malware that hacks into this kind of phone, it doesn't do it because they've got some guardrails in there to stop ChatGPT producing harmful code and harmful material. But the bad guys have built something called the worm GPT, which does exactly that. You can go in there and say, I want a malware for, this make of phone and this model, and pops out the code. So that is already happening on the dark side. And of course, the issue of what can you believe? Can you believe what comes out of, social media? Can you believe what comes out of the end of a phone? Can you believe that the person you're talking to is who they say they are? It's getting more and more difficult because AI is being used to create fake identities, fake videos, deep fakes, fake content, and so on. Now, these things are not new. Deep fakes have always been possible, but in the past you needed a studio crew and a studio to actually create it. Now, you could download an app and create something that is pretty good in terms of quality as far as its low resolution. As if you zoom in and start looking at the resolution, you might be able to detect that it's fake. But a lot of people don't do that. So the bad guys are fast at work trying to create AI systems that crack your password, generate malware, and create fake identities. And I talked about encryption, and it's not just enough for our IoT systems in the future to have encryption, because we've got the threat of quantum computing coming. And the bad guys, some nation states in particular, are quite advanced in building quantum computers. And once they do that, the network encryption algorithms that we use today, 99% of them are susceptible to quantum computing attacks. So we're hard at work in trying to figure out what kind of encryptions can we use in a post-quantum world. So we've got some hardware-based solutions, and we're also working on algorithms released by NIST recently. Those of you who follow sort of quantum computing probably are familiar with this. The problem with these algorithms is that they're run on powerful computers and devices, network devices. But what about IoT devices? Do they run on those? Well, that's what we're working on. One of the things that we're working on is lightweight encryption for IoT devices. This is some work that we're doing with the University of Ulster in Northern Ireland, and we're kind of looking at different type of algorithms and what kind of performance we can get out of them for low power devices and so on. And this is the kind of work that we need more of in terms of protecting the communication from IoT devices, but also actually protecting the data in IoT devices themselves. Vulnerabilities of AI systems. Many AI algorithms that are used for classification of, labeling data to say, well, this is malware and this is not, suffer from what's called adversarial attacks. And these algorithms have been proved to be susceptible to what we call poisoning attacks. So when you train the data, you inject bits of noise into that data so that when they're in operation, they fail catastrophically. This vulnerability has been shown by researchers on self-driving cars, for example. The algorithms used to recognize objects have been subject to this kind of attack by putting some spray paint, for example, on stop signs or some sticky tape on specific locations on a stop sign, which would force the camera to misrecognize that as a speed limit sign, and that causes obviously catastrophic failure. Or not recognize it at all in this case, by putting some objects on this here, it doesn't recognize it as an object at all. And these will be exploited. And if you put this kind of algorithms into your devices for protection of your device, obviously they have this built-in susceptibility to attacks. So part of our work is what kind of algorithms have what kind of vulnerabilities, and how should you avoid this in sort of safety critical systems. So now I'm coming to where AI can be useful and can be used to kind of protect us from attacks. One of the projects that we're doing is kind of real-time anonymization of, say, for example, content or images. In this case, it's images. I thought this was playing automatically, but this is not. Is this a video playing? Now it's playing, okay. So this is based on policy-based real-time analysis of videos. And what we can do is we can make sure that only the people who are supposed to be visible in this case are visible. Everything else is it's covered and the privacy is preserved. The other area where we are putting AI into IoT security is home security. As you know, we have a very large presence. We just launched the EE brand for all our BT customers, and one of the things that we're doing is we are upgrading our hubs, our home hubs. The next generation, you don't have these yet, but they're coming. Next generation of these home hubs will have the capability to have a lot of processing power in them, And what we're doing is we're looking at anomaly detection software that we put in those home hubs so that when people take their IoT devices, mobile IoT devices or fixed IoT devices, and they use them at home, the home hub has the capability to automatically detect vulnerabilities, and then based on what the customer wants, do something, either clean them or update them or just send an alert or whatever the customer decides they want to do with that, without losing the service. So this is much more than just a firewall where you sort of block a device to say, well, this is infected, you can't use it anymore. And we're using the network back end to actually analyze the traffic from an infected device to actually gather more information about what the vulnerability is and how we should learn from that vulnerability for future releases of the anomaly detection software. This idea of authentication at zero trust is quite a big initiative in BT right now. Zero trust network, I think, are very suitable for IoT systems. And one of the things about zero trust is that you want to have very strong authentication. And passwords are probably the most hated security technology out there. And what we're working on is a technology called continuous authentication. And this is quite pertinent to a gathering like this, because I think continuous authentication is very useful for people and device authentication in the future, whereby you sort of move away from one-shot authentication, where you move away from the dependence on passwords. And we've got a project here called continuous authentication. We're testing it on mobile devices and on desktops at the moment. And the idea is that you collect a lot of behavioral biometrics and keep it in the device. So it's on the edge. You don't collect it in the cloud and analyze it. You collect it in the device, and the device itself has a model of how its user is supposed to use it. And then this is the desktop version that we're using for privileged access account. Let me just see if this works. Yeah. So this is the this is the version that uses the webcam to we train the system for an hour, and then it uses the webcam the first time you register because you need to create a profile, and then once you do that, then you don't have to put your password in anymore. That's the end of it. In this version, that's the way we're using it, and now we've got a guy called Max. Max is the legitimate user of this sensitive system. And once Max sits in front of that camera or in this desktop system, access is granted. You can also see the trust. As soon as there is a person looking over Max's shoulder, the trust goes down. Max disappears, system is blocked. As long as Max is not there, obviously there is no legitimate user and it won't be authenticated. As soon as Max moves back in, you get the trust back up and then you have access to the system. This is the human version of continuous authentication. The device version is also quite interesting. There's some work around in Essex University called isometrics with some of our colleagues, and they're trying to do the same thing with devices and so on. And I think that would be quite interesting for IoT systems. Next. Okay, so the other way I think AI is going to be very useful for IoT security is generating secure code. So there are already some examples of systems like ChatGPT, large language models trained to spot vulnerabilities in code and so on. And I think this is going to be quite powerful and quite useful for checking the firmware of IoT systems, for example, or introducing security elements into those for companies that don't have that capability. We are also working on a system. I'll show a bit of this later on. How much time do I have, John? 10 10 minutes, 20 seconds, okay. And so I think that ChatGPT is extremely powerful, and we will be using it, but we won't be using it for the most secure stuff for obvious reasons. So we're actually developing something we call sort of ChatGPT++, which I'll show you in a bit. And I think that's really useful for analyzing the threat environment, particularly unstructured data. And I'll show you a version of this. And I think LLMs are going to be quite important in doing this kind of stuff, not just answering questions, but actually being able to create knowledge graphs of the threat environment and link the threat actors and the devices and the vulnerabilities together for a company that's producing some kind of detection and response capability in IoT in the future. So I've got a few examples of some of the systems we developed in my team. This example uses AI to find suspiciously newly registered domains. As you know, one of the ways that the criminals get people to give up their credentials is they send social engineering emails and so on to the victims, and then they create bogus websites for people to go to and then put their credentials in and so on. And one of the things that we do is we take down these websites. And this system, we get hundreds of thousands of websites a day that are created on a daily basis. This system is a threat hunting capability where AI reduces the volume of the newly registered domains to the suspicious ones. And what you're seeing here is one of our Security Operations Center analysts investigating the relationship between the suspicious domains and the known malicious domains. So this is something that affects a lot of companies, banks particularly. And what the AI is doing is reducing the volume of the data so that it becomes manageable for a human being to do the final check, essentially. And that's what you're seeing here, the interaction between the front end, in this tool called Nexus, and the data is to make the final decision in terms of, what's the final list. And the final list is quite small, actually, at the end of the day. And this is what I was talking about in terms of keeping the human in the loop. Because if we do this automatically, we're going to get a lot of websites blocked that are legitimate. And what we do here is we put the human in the loop. This is another use of AI for ransomware payment, tracing ransomware payments. This was actually a real investigation. Obviously, I've changed the data. But the idea was that after a ransomware attack, we wanted to know where the money goes. And what we've done here is we've designed an AI system that identifies suspicious payments into Bitcoin wallets. Of course, Bitcoin wallets are open. Everyone can access the data. The problem is you don't know who owns them. And what the criminals do is once they get the ransomware payments into a few wallets, they transfer the money into another wallet, close down those wallets, and then disappear. And speed is of the essence here. So in this case, what AI does, it produces that almost instantaneous classification for us to say, these wallets look suspicious, and then we work with the law enforcement agencies, and the other wallets that we see here are known criminal gang wallets. And what we're looking for is a transaction between these, and then that information is then passed on to the law enforcement agency. So AI does the kind of heavy lifting. At the end, still a human looks at it and say, yeah, this makes sense. Let's pass this on to law enforcement agencies. Automated response is an absolute focus for us going forward. We have a global network, and one of the projects that we're working on here uses epidemiological modeling of the network. These could be IoT devices or normal network devices. And what we want to understand is, can we model the interaction between elements in a network using epidemiological modeling? So what we're interested in is, if there's an infection at one point in the network, how long does it take for it to propagate? Exactly the same way as the government was doing COVID modeling, we want to do the same thing. So what we do here is we build a model of the network and then use it to understand how certain infections would propagate. And then the second stage of this project is we want to use automated reinforcement learning agents to use that simulation environment to find the best action possible at any moment in time. So what you see here is an action that has been learned by a reinforcement learning agent in terms of best way to defend this network, or best way to contain the infection. Essentially, that's what it is. This project is currently being trialed on our system, but I think the idea of just automating everything in security is a dream. I don't think we're going to do that. This is a step in that direction, in the sense that we're using machine learning and simulation to try to build some confidence into the actions that AI would take to stop the attack. And then what we do is we observe our agents, our SOC analysts, to click on these actions. And if they always click on the top action, we automate it. If obviously they don't, we try to feed that back into the reinforcement learning. It's a bit like getting a robot to learn to drive in a simulated environment by letting it crash your car as many times as possible in that environment, right? That's what it's doing. How much time? 3 minutes. Right, I'm moving now. So the same kind of AI tools are being used to model how an infection goes through a smart city, for example. This is a collaborative project that we did with those partners up there. And this is looking at particularly social media data to understand that a self-driving car or a smart car has been infected, and then using that to understand how long it takes for the whole city to get infected, or how long does it take for that to propagate. I don't have time to go through this one. This is the project I was talking about, ChatGPT++. So this is about building knowledge graphs of all of our unstructured data we have in our business. And it's a live system which enables our analysts to look at relationships. This is a knowledge graph. But behind each one of those nodes, there is quite a big document which has been summarized into this front end. And what the analyst is doing is essentially saying, okay, I want to know more about this one. And in this case, it goes into the group R-Evil and so on. And I'm going to finish on a high. And of course, I think in the future, you probably want to have not only prevention-based security for IoT, but also detection and response capabilities. And because of the volume, you've got to reduce the sort of cost of creating these environments to analyze what's going on in the world. So one of the projects that we've got is called Virtual Security Operations Center. This is an entirely virtual space whereby you could put an Oculus Rift and do the investigation based on interaction with the data using some of the tools that I've already shown you. But also you could work with robots, in the same environment. You could have an agent that is not actually a real person, and they could have expertise in anomaly detection or expertise in particular devices, and you can call them and they can come into this environment and interact with you and answer your questions and so on and so forth. And this is one of the kind of future projects that we're working on, to build these environments within an hour, do the investigations, find the vulnerability, and then delete them. And that is all I was going to say. Am I on time? Yep, you're good. First time this year, I think. Thank you very much. I'm sticking around. If you have any questions or you want to have a chat with me, please come and find me during lunch. Thank you.